Okay, welcome. And today we're going to do an example that it's going to be the last example for this topic. And this is going to involve, what if you have a region bounded by two different curves? Okay, so we're going to do that one. So let's say we have something like this. We have g of x equal to 1 over x, and we have f of x equal to this, the square root of x. And we want to bound it also between x equals 1 and x equals 4. So the orange region here, that's the bounded region. And we're going to rotate that region around the y-axis. Okay, so now the only difference is that now our rectangles go from the top function to the bottom function. So instead of our height of a rectangle normally being f of x, right, which measures the height above the x-axis, now it's going to be the height of the f of x, right, minus the height of g of x. So basically we're going to take the distance from the x-axis that we get to go to f of x, and we're going to subtract the distance to g of x. And so now our height of a rectangle is now going to be replaced with this. And that's it. That's the only difference. Okay? So let's do it. So now here's the setup. We want to find the volume of the solid of revolution that is bounded by the region f of x equals square root of x. By above, it's bounded above by this, bounded below by g of x 1 over x, over the interval from 1 to 4, and we want to rotate it around by rotating the region around the y-axis. Okay, so again, remember our formula. Volume equals a to b, right? Integral from a to b, 2 pi x f of x dx. But now this height of our rectangle is no longer that. The height of our rectangle is now going to be f of x minus g of x dx. And now we're ready to go. So let's fill it in. So this is going to be from 1 to 4. And so I'm going to pull the 2 pi out. And so this is going to be x times f of x minus g of x dx. So now let's simplify more. 2 pi. Okay, so this is going to become x to the 3 halves minus 1. Okay? Again, if you don't see that, just write it out in more steps. Distribute the x to both of these, and you should get this. And now I'm going to integrate term by term. So this is going to equal 2 pi times, so this is going to go to 5 halves, so I'm going to have 2 fifths times x to the 5 halves minus x, evaluated from 1 to 4. And again, we'll do this the same way that we did before, 2 pi, and we're going to get, it'll be 2 fifths times 4 to the 5 halves, which is going to give you 32, minus 4, minus, now we're going to subtract off the same thing evaluated at 1, which is just going to be 2 fifths, 1 to the 5 halves, minus 1. Oops. Okay, and if we simplify this, what do we get? We get 2 pi. Now let's simplify this. Like I said, this is going to give you 32. And then 32 times 4 is 64. So you're going to get 64 fifths. Minus, so this is going to be 20 fifths, right? Minus, this is going to be, again, 2 fifths minus 1, which we can call 5 fifths. Oh, hold on. Oh yeah, that'll work. Okay, that's fine. And so now, what do we get? This is going to give us 44 fifths plus 3 fifths. So it's going to be, right, so again, this is going to give us 44 fifths, and then this is going to give us a negative 3 fifths, but the negative cancels, so it's going to be plus 3 fifths. So 44 fifths plus 3 fifths is 47 fifths. And so we get 94 fifths pi as our answer. So 94 pi over 5. Let me just check to see if that's right. Yes, that is correct, and it's cubic units. But again, you can change this into what? We could change that into a mixed number, which would be 18. Yeah, 18, and it's not coming to me. So divided by 10, it's 9.4, so 18.8. So it would be 18.8. So 8/10, so 4 fifths. So it would be 18 and 4 fifths pi. That's it. Have a great day.